Jai Hind, the viewers. Welcome back to another episode from our platform. Today we have with us Lieutenant General Dr. Anil Kapoor, AVSM VSM. He served as the Director General Electronics and Mechanical Engineers and Director General Info Systems. A chartered engineer, he was awarded the Eminent Engineer Award 2020 by Institution of Engineers. He is a professor of practice at IIT Tirupati and also a board member in their innovation hub. He writes and speaks on emerging technologies like C7, ISR, and AI in many publications and platforms. He is a regular contributor to our contributing member in our forum, and there are a very large number of his interviews which I recommend you must go and see. So, General Kapoor, the first question to you is that what are the future technology trends in equipment according to you? Anil, please.
Thank you very much for this, sir. When we look at equipment in the contemporary phase now and foreseeable future, there are four very important terms which are related to technology which come on the fore. The first is automation. The second is autonomy. The third is precision. And the fourth is positioning. I think these four terms encapsulate the technology landscape of future equipment. Let me go one by one. When we look at automation today, automation means that we need to fix two things: sensors and IoT and software. So if we were to fix this bit, a lot of data gets generated and data management becomes a huge issue and a huge challenge, but at the same time, a huge opportunity, because it makes the equipment talk. Something that I alluded some time back, it humanizes the asset. And therefore, automation helps you in gauging the health of the system at any point in time and in real time. It also helps you in being able to use the equipment optimally. And that is where the future lies. The second is autonomy. With a huge amount of data and big data which is available today, there is a need to look at autonomous decision making. In fact, ADAS is a great system in vehicles today, where the vehicle on the cruise mode actually goes on its own. And it's a very simple autonomous, semi-autonomous action. And should it find the vehicles around in a manner that it needs to reorient itself or brake, it takes appropriate actions both in terms of steering and in terms of braking systems. So really speaking, it is the data which is governing, and artificial intelligence which is actually doing all the analytics to give an autonomous decision. The third is precision. Now, everything today is very precise in time and space. The technology today is changed in a manner that everybody, all of us, have got so used to Google Maps that if you were to think back that when Google Maps were not there, how would we actually reach from place A to place B? It appears archaic. And therefore, today precision is all about being able to know, and I'll take again the example of a Google map, that if you started from a place A at a particular time, what time would you reach the intended place? And therefore, you could plan your time accordingly, your travel plan accordingly. It tells you exactly what routes to take, because it also gives you what is the precise problem all along the route, whether it is in terms of traffics or in terms of any other interference that could be there. So really, precision is all about giving you the right situational awareness at any point in time. And the fourth is positioning. Today, everything is GIS enabled. Even when we are looking at Blue Dart or anything, and we get a code, we'd like to know, where is my parcel reached now? And being from the defense, both of us, at any point in time, we were very concerned about the positioning of most of the assets that would leave our headquarters. And In our terms, we would say, okay, please communicate from the nearest place. But today, everything is available in real time. So, really speaking, these four things, when we talk of automation technologies, autonomous technologies, precision technologies, and positioning technologies, and there's a huge, huge landscape. I'll not take time here. But these technologies put together give you two things: a real time and a common operating picture, which are very, very important both for individuals, for teams, and for organizations. And therefore, I think a future equipment should qualify to give you all these so that it becomes part of the ecosystem. Some time back, a telephone was for a machine to machine talk. Sorry, from a man to man talk. Today, it is a machine to machine talk. And therefore, when we look at a machine to machine talk, there is really an ecosystem of manned and unmanned systems, of man machine mix, of human computer interface, and therefore all these interfaces make everything part of the ecosystem. And the future equipment must make sure that this ecosystem is well served for the purpose that it is made, whether it is a military equipment or it is a commercial equipment.
Thank you for that, Anil. So from that, the next question arises that you had also sort of mentioned it, that how can we manage legacy equipment? That is a big challenge. Anil, please.
Very good question, sir. When we look at legacy now, actually the technology is on a gallop. And the technology obsolescence cycles, which maybe in 70s used to be 4 to 5 years, in 80s and 90s it became a year. And now I think when we look at beyond Y2K, the gallop is huge and the changes are happening at a very fast pace. And therefore, legacy equipment or legacy systems are going to become a norm. Now, there are, firstly, each organization, therefore, must enable itself by, and all the chief technology officers must enable themselves to make sure that they understand as to the systems that they have, uh, how much of it is becoming legacy and how do you improve upon it. Coming closer home to defense, I think this is a big, big challenge, a very big challenge, because in our case, the quantum equipment that you procure, the legacy footprint is huge. And therefore, I think it's a good three-step process. The first step is identifying critical pieces of equipment. The second step is identifying what is obsolescence or what can be improved upon. And the third step is designing and developing technologies which can be built into the legacy systems to make them as compliant to state of the art as possible. I think if organizations follow these three steps, it would be easy for them to fix legacy as a systemized approach, because it requires a systemic approach. It requires understanding of technology. It requires understanding of the equipment. More importantly, it requires you to know as to what I need most critically, what is the cost benefit of technology that I put in, and what are the dividends that I'm looking at. So if we were able to answer these few questions, I think we would be able to manage legacy very well. To my mind, today it is a compulsion, it is no longer a choice. And organizations which embrace this management of legacy equipment as a strategy would do very well in times to come. We all know today we have digital twins, and the aim of digital twin is basically to uh, emulate virtually the complete equipment and identify areas which could be improved with time. Seek feedback, and once you have feedback, get into product improvement and product development and redevelopment cycles, design and redesign cycles. So I think what I always say, agile leadership and agile technology leadership has to become a norm. So it is a change in HR practices, a change in our own mindsets, and creating the toolkits in organizations and skill sets to be able to manage legacy. So, in an overall analysis, therefore, I think uh, managing legacy has to be part of a very cogent strategy.
Yes, indeed. Thank you for that. For legacy equipment, you have given out a nice way of handling it, and it could be of value to a lot of our viewers. And my final question today, Anil, to you is, what are the future trends in MRO? Anil, please.
Uh, thank you for that again. Now, today, as a user, I think we used to talk of user satisfaction. I think today there's a huge need to understand the user dynamics because given the technology landscape, every user would like to have an equipment which ideally does not fail. It is like the iPhones that we have or any other smartphone that we have. When you buy it, actually these equipment tend to be maintenance free. We've all been looking at a lot of electronics. We've been using a lot of electronics, especially in defense. And you're very chary about downtimes. We've always been chary about downtimes. I think time has come when nobody accepts downtimes. More importantly, in organizations, commercial organizations, which are manufacturing units or industrial units, uh, every piece of equipment which is associated with their production, they would ideally like to it to run 24/7, 365. And therefore, the future MRO practice is about being able to predict and prescribe maintenance. So the yesterday role of periodic and preventive maintenance, which it played very well given the technology landscape of yesterday, I think those were we are all used to periodic and preventive maintenance as being a reliability centric process. I think there's a departure now. The MRO trends of the future have become predictive and prescriptive. Nobody wants to do a downtime at a time when he's high on production. And therefore, there is a need to look at the whole system in a manner that we can have scheduled maintenances, and that will require, like we said first, it'll require visibility, it'll require exactly getting to know what is in the green zone, what is in the amber zone, and what is in the red zone of operations. Any system that is in amber zone uh, actually should come on the lookup display of maintenance engineers to be able to look at a window which will not affect production and get into a suitable maintenance program accordingly. And therefore, I think the maintenance engineers have to create agile systems amongst themselves for maintenance, which are more based on predictive and prescriptive trajectories. The second thing is that the inventory holding costs. I think we've all seen the just in case kind of maintenance where the inventory holding costs are very high. And therefore, the new paradigm is just in time maintenance. The amber zone gives you enough notice. And I think there is a need, therefore, to identify what is critical and only have that much of inventory held on hand and the balance available on call. So when we look at the inventory management, which is a very important part of this practice, there is a need to look at it that way. And I'll quickly allude to a couple of pillars of maintenance. Uh, when we look at skilled manpower, I think skill is a new collar. And I've been saying that time and again. And the reason is that all of us need to upskill ourselves regularly. The technology is changing very fast. Today, we've seen the change from analog to digital. Today, we are witnessing the change from digital to quantum. And a lot of AI getting into it, a lot of data management getting into systems, sensors getting into systems, semiconductor technologies, software technologies, AI, generative AI. There's so much happening. And therefore, I think upskilling at all levels is very important, given the role that each one of us has. So that is when we look at skilled manpower. When we look at the second pillar, which is say test equipment and tools, I think we need to build in a lot of test equipment, which is possible today by sensors and IoT, and therefore we create a humanized asset, a digital asset which actually speaks and tells you what is the health of the system, exactly like a human body. So I think that is the second thing on test equipment. When we look at tools, I think we need to look at diagnostic tools which can remotely communicate. So we are not looking at physical tools which are definitely required wherever they are required, but we look at creating toolkits for remote access. And that is yet another paradigm. A lot of robotics is getting into it, so we need to look at that. Inventory I've already alluded to, but I'd like to add that 3D printing has to become, and smart additive manufacturing has to become part of systems which are maintenance systems, including in the defense forces. We need to look at smart additive manufacturing in the TBS as well, to be able to manage the needs when there is a sudden catastrophe. And here we have to be prepared for both what we call the M kill and the K kill, to look at scavenging and 3D printing as a combination. Uh, One more pillar which has become very relevant today is technology and data. I think these are two new pillars which have got added. And as MRO specialists, we need to be very, very cognizant of these changes in technology and how they can be adapted to systems. But I think today a maintenance engineer task is not only maintenance, it is to do a lot with identifying technology obsolescence, identifying technology updates, designing and developing them. And therefore, today we need to have a very formal design and development wing as a part of MRO, so that whatever user feedback you get, you are able to get it into product development. I am aware that we in the core of EME do have an ecosystem available, but I'm also aware that in the commercial space, this ecosystem is, in some cases it is already there, in some cases it is outsourced. But I think in a future MRO perspective, all organizations have to look beyond production. They have to look at life cycle management. And when we look at life cycle management, I think product improvement, product development, technology obsolescence, technology upgrade are very important, for which this vertical of technology and data actually takes the center stage. So I think when we look at the future MRO, we have to look at a guarantee that we give, a SLA that we give to the user or to the customer, that take this equipment, we will tell you when to maintain it. If that is the kind of confidence an organization can get into the equipment, I think we would have done a great job as MRO specialists, because maintenance on demand and reducing the breakdown maintenance footprint. So really speaking, we are into preventive maintenance through predictive maintenance, if I may say. And therefore, that change has to be understood in MRO. And if we understand that change, then everything that goes into facilitating that change has to be incorporated. I think these are very exciting times for all of us, because we see so much happening. In fact, I'm in the US, and yesterday I happened to see a demo on the driverless car here in Boston. Since we're going to have shortly the US Day on the 4th of July, a lot of technology is on display by students and others. And one sees the excitement that is there at all levels in how technology is bringing in major changes. I was also reading a piece of news that in Delhi, the Magenta line, which is the metro line, is going to go driverless from tomorrow. So really, these are some of the changes which are happening. And when we look at driverless operations, and from MRO perspective, we have to make sure that it is fail safe. And that is where the challenge lies. I think I'll end at this.
Thank you very much, Anil, as always, for sharing your wisdom, your vision. It's always a pleasure listening to you. I also thank you on behalf of our subscribers and viewers. And viewers, with that, we come to the end of this particular episode. We look forward to bringing more such episodes to you. Thank you for tuning in. Jai Hind.